Well, all right. Thank you so much. That's good. Cool beans. Okay, everybody. So, yeah, hi. I'm Dr. Dodd. Thank you for that lovely introduction. So today, yeah, the plan is I am gonna backtrack a little and repeat some like show you the key links again, if that's okay, just because I think it's worth repeating some things a lot. And kind of give you a little bit of an idea of when what you can be thinking about for your concurrent sessions next week. And then we'll talk about, yeah, when would I use, or, should I go to R sessions? Should I go to Python sessions? When would I, choose R over Python? Usually, folks they choose a language and they run with it, right? Or they learn both and they use them for different applications. We're going to go into all that. And then I'm going to go to the repository and we're just going to open some data. And the whole point of it is so you can see the process. So, like when I open a data set, in fact, I've done a cursory glance of some of these data sets, right? And I think it's good that I'm not super familiar with them because you guys also were not super familiar with these data sets, right? They're new to you too. So I think it's nice for you to see somebody who does this regularly, what our thought process is. How do I come up with a question based on the what I have here, right? Because sometimes when you open a data set and it's got 30,000 data points and the columns are going on and on and on, you go, oh my gosh, what? Ah! Right? And it's really, if you do it enough as you learn and you go through this process, you can find that it's actually, it doesn't have to be intimidating and scary. Okay. So I'm going to share my screen to show you. We're going to just really quickly check out the key links. Where is it? Okay, let me pull it up here, you guys. Sorry. So, and I'll also refer to, kind of the project guide so you can kind of see how this fits with that. Um, so just really quick though, because I think when you have like 100 people on Zoom, it doesn't hurt to repeat stuff a lot. So if you're like, well, yes, we've heard this a lot. Well, maybe somebody didn't. So okay. So the key links, I'm showing you this because like, oh my gosh, this is so organized. Like this makes my brain so happy. Everything you need is in this sheet. I can
I
say,
want
look,
to jump in because there
yeah.
is a wonderful thing that is opened here on Dr. Dodd's computer. If you look this little tab, if you click on that arrow back here on the left, normally you'll see this, okay? But if you click that, you will see that it is a nice table of contents. So if you're looking for a specific day, you can just click on it. It'll go to that day. Does that make sense? So it's really, of course, we don't have anything for Friday yet, right? It's just happening right now, but you will once we upload it. If you need, let's say something about prizes, if you scroll up, there's a prize tab. So if you're having trouble because it's getting longer, it's right there. And it goes right there. So please, you guys, everything is here. I promise. Again, if you still can't find it, it's okay. It's only day 2. We can still help. We'll still help. And eventually others will be helping you. Like other students will be jumping in. It's awesome.
Mm-hmm. Yeah. Yeah. And what I love most about this too is, yeah, sometimes you want to go back and rewatch a session. I'll be real with y'all. I'm going to be watching some Python sessions because I'm trying to up my Python chops myself, even because I'm an R person. So, like, you can just go to the day and go, oh, yeah, okay, well, okay, that's going to be later, right? But, right. And find that Zoom link so you can go back to the video. I love that. That is just wonderful. Okay. So there's that. Now, really quick, I also want to throw out there, like when you look at the schedule, um, and I'm sure Dr. Holden and Dr. Krakowiak have told you this, but like, okay, first of all, I'm just gonna give you the info. Like today, we're not doing stats today. We're gonna talk a little bit about stats, but we're not even gonna really dive deep into stats until Monday. I'm sorry for those of you who are like, stats. I would be the same place as you, be like, huh. But review is always good. And also, let me just say, when somebody kind of backtracks and you hear something from a new person about how to do something you already know how to do, sometimes they give you new tips and new tricks. So you can still be adding to your toolbox. So, but Monday we'll jump into, or excuse me, I Yeah, there we are. Monday we'll jump into stats. But I wanted to point out the concurrent sessions, and I'm sure they've told you this, but you get to choose. If you are a baby in R, then you would come to the beginner section, right? I don't expect you to have ever even opened R if you come to that. But if you have, that's fine too. It's mostly like folks who are not quite super duper comfortable with it yet. And then, let's say you get there and you're like, oh, wait, no, I know how to do all this. Oh, no. Oh, what do I do? I've made a mistake. No mistakes, no problem. You just go back out to the main room and you can actually switch. Now, you don't want to like switch back and forth, right? Because you're going to miss stuff. But you can change if you get into a session and you think, oh, no, I'm in the wrong session. You're not like, you're not married to that session, if you will, right? You can always change. So that's not a big deal. So, and that's when we'll get into stats. And Tuesday is when we start coding. So we're not coding today. I'm sorry, but we have lots of code for you. So you're going to have so much code by the end of all this, but it is not this day. So we're mainly just going to talk about like making your questions today. All right. So let's see. Let us now talk about um, the R versus Python question. Now, let's see how. Okay, I'm going to go through all of these too. These resources and links are great. I'll do that in just a minute. I just kind of want to talk generally about R and Python right now. So let me, I have a little, I'm going to stop sharing this because I'm going to share something else. Share these slides. Uh, okay, that were so nicely made for me. But so, if you're not sure what to use, I hope this will kind of help resolve some of your questions. I'll tell you, when I started using statistical computing software, I started using statistical computing software, I guess, 15, 16 years ago, but it was not R. R's been around actually for, oh my gosh, like 30 years now, technically. It began about 30 years ago with two guys. But you know, it didn't really gain a lot of popularity until probably probably about 15 years ago, 14 years ago. And so when I was starting out, you were told what language you were going to learn. You were like, listen, you're taking this class. In this class, we use Python, or in this class, at least the classes I took, we use R. And that's what I tell my students too, even though they are welcome to learn Python, of course. It usually just depends on the class you're in, right? Usually you don't have the freedom to choose. You're like, oh, I'm locked in to R. Well, that's what I'm learning, right? So I think that's what's super fun about ASRI is you get to choose. Oh, so nice. Okay, so here we go. How do you choose though? You're like, I don't even know what to do. And this is a PDF, so let me do it as a full screen, if you will. I appreciate your patience as I navigate the zoomingness because sometimes it's a little slow. There we go. Okay, now. So here we go, some comparisons. So we're just gonna riff on this for a minute. But if you have a question, let me know. I'll, I can answer any question you have about R. I will be honest with you.
If you guys want to raise your hand, that's okay, but you can
Yeah.
also put it in chat. If I know the answer, it'll make things go faster.
Yep.
For example, the current question is,
Yes,
what's
thank
the
you.
difference between R and Python?
Whoa,
Good.
are you in the
Perfect.
right place? Yeah. Cool. I'm about to tell you. That's awesome. So, um, I will say also, sometimes you have, I probably won't keep up with the chat so much, so you can just, yeah, raise your hand or like, excuse me, are we going to use our studio or just our? We're going to use our studio. I think our studio, and I'm going to show you our studio today, just briefly. We're not getting into it because in the beginner R sessions, I am going to literally hold your hand and I'm going to guide you around the R everything. I don't want to say environment because that's actually a window in our studio. But the forest of R, I will guide you through step by step. So yeah, yeah. So one thing I will say too, you're not locked into a language once you learn it, right? Like I have been using R for over a decade. I'm very well versed in R, and I've been trying to kind of expand my Python capabilities and proficiency because, well, I mostly for me it's just fun. I don't actually need it. But if you're like a comp sci person, or if you're going to do some heavy machine learning, and I mean, I do machine learning in R, and that's what I'm going to teach it in, but like if you're going to do humongous data sets, you might learn Python first. Some people do both. Like Dr. Fowler is a data scientist, and a lot of data scientists, they kind of go between depending on what they need. Um, so we're going to talk about that though, because it also kind of depends on your field. So we'll get into that. Let me just I'll just tell you about like the straight comparison here first, okay? Um, so both of them are open source, which is awesome. It means they're free. You can change computers and re-download it. You never have to buy it again. And this is amazing because I've been able to have continuity with R, and this is true for Python users for over a decade. There is a ton of online support. These, like the Python, there's a Python community, there's an R community, and so you're able to like always find help. In fact, the first class I ever took that was Intro to R in graduate school, our teacher, her professor did not give us template code. She said, I want you to figure out how to do these things. It was a list in the next 2 weeks. Go figure out how. And so actually it was the online community that was teaching me R. So that's nice on both sides there. Both free web-based coding environment, which I'll talk about. That's RStudio. A couple of things in Python, but RStudio for R, and then free desktop coding environment for both. Now, here's the deal. The big difference, really, to me, is says can handle really big data sets slash tasks. Now, I want to tell you, without a high performance computer, without a high performing computer, um, I will say I have pretty large, I would say, data sets. A data scientist would tell you my data sets are not large. I've had tens of thousands of data points, from logging data at a site every 15 minutes with a logger for a year that you download over several months, right? R has been able to handle those. So when I say big data set, I mean like, ugh, blow your mind big. We're talking about like huge modeling projects, big time deep learning, machine learning, AI, big like type projects. So like if you're more comp sci, so this is where kind of R versus Python depends on what field you're in, right? Because like Python, I think of you're a data scientist, you're a comp sci person, right? Um, you're doing really complex modeling, or you need like a really general environment because you're programming for one application or for some reason, right? But you need to switch between why you're using it because Python's more general. Python is like you have a big standard library, general applications. R was developed specifically for statistical computing. So R is like, I really just want to do stats and modeling. You can model in R, but it's a little more specific, if you will, to statistical computing. Yes. Yeah. Some consider them rivals. Oh, yeah, I don't feel that way. I love like my friends like who are Python people. I work with people. Actually, I just had a paper and we were like some of us were R people and some of us were Python people. You use libraries like Pandas and R. There are libraries. They're not the exact same as like Pandas, like you'd have in Python, but there are, yes, there are. Sorry, every time I say R when I'm talking about R, I laugh. So yeah, there are. Um, what would we consider as big data sets? Right. Okay. So in the repository, I'm gonna be honest with you. Everything I've seen, okay, I could be wrong because I haven't looked at every single data set yet because I'm still getting familiar with it, which is fine. But what I have seen so far, I could use either for all of it. Now, Krakowiak and Holden can correct me if I'm wrong there, but all of those, from my knowledge of R, you could analyze in R or Python.
There,
So,
there were in the past a couple of data sets that were too big, and I think Jennifer removed them.
okay.
And if you have a data set that's too big, that is something we can analyze in pieces or select a small subset. So yes, your data set should not determine which one you're going to use. Having said that, there are some data sets that are easier to handle in R. But I think as a biologist, R is the language of us, right?
Yep.
So in biology and medicine, a lot of people, bioinformatics, a lot of people use R.
Yes.
But if you want to learn a coding language and that's your priority here with us, which isn't really what our whole goal is, Python may be the better bet for you.
Hmm. Yeah, and somebody asked here, yeah, both languages are a little similar. If someone knows Python, then R will be easier. Yes, that's true. That's the thing. Like I know some Python. I can do Python. So because I know R, yes, there actually is some similarity. Though I would say Python, the Python syntax as you're first starting out, I think is easier. With that being said, I learned R and that's all I learned. And it hasn't been a problem for me, and it made Python actually even kind of easier. Like I yeah, I have to take biostats this summer, so R would help with that. Oh, probably. You should ask your stats professor what statistical computing software they want to use, but a lot of folks use R nowadays. Some people do use Python though. Does R's computational power, is it similar to SAS, EM, or EG in regards to modeling stats? Yes, it is. I mean, R, I don't want to come across as R being like, like a baby statistical computing software it can't handle a lot because all I've ever done is model ecosystem processes in R with pretty large data sets. But Python is just like really huge, complex, deep learning, that kind of stuff. I think of like data scientists, comp sci people are more likely to use Python most of the time, use Python. I'm a biologist. If you're a biologist, zoologist, any kind of just kind of straight, like I go out and I collect data, you know, um, if you're in the lab, R is going to be fine. R is going to do everything you need. I mean, I've done meta analyses with lots of data um, in R with no problem. It's very powerful. It's not as powerful as Python because Python is more general, right? It's also what we would call object oriented versus R is what we call function oriented. If you have no idea what that means, it don't matter then. Like, but if you are a comp sci person, you probably get what that means. If you don't get it, that's okay. I don't want to like freak you out. So yeah. So it says someone knows Python and R will be easier. Yeah. I think it's the other way around. Honestly, I think if you know either of them, it's kind of like, now I will say, well, and here's the other thing. I have looked online. This has happened. I mean, I've done it over the years even just to see. I've checked Reddit before my biostats class because I've had people who already knew how to use Python and like there seems the jury is out on like which is easier because some people are like, I think if I was just looking at the syntax, Python actually does seem easier to me. But some people are like, no, 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 R is easier. So it actually I think depends on you too. Yeah, if you've used SAS, I mean R is different, obviously, but yeah, that's good. That's good. I have to take, oh yes, R will definitely help. Oh, thanks, guys. Okay, sorry, I don't want to spend too much time on the chat, but I'll get on with it. I don't yet. Okay, some of y'all, actually, those of you who are answering the chat are doing a great job. So I'm gonna let that fly for now and let that ride. So that's the deal. Like for me, um, you know, I use R for all applications. I'm not telling you to use R for all applications. If you are a comp sci person, if you're gonna do some crazy data science modeling with, I mean, we're talking, I would say like way more than just tens of thousands of data points. I mean, we're talking large, complex data sets, then you would use Python. But our most statistical computing, it will handle that. It really just depends on, yeah, I think really your field and where you want to go. Like you might also do a little bit of research. Here is in my career, I want to go over here and do this stuff. What is everybody else doing, right? Because that's really why I mean, in my program, we all learned R because that's what everyone, in ecology and the environmental sciences they tend to use. And honestly, a lot of biologists use R, but not all. Some of them use Python. So, okay. And if you're not like, if you're scared of stats, don't worry, because we're gonna hold your hand through that too, y'all. Don't you worry. So, yeah. Okay, so, mm, but yeah, they can both handle if it's a smaller data set. That's fine. Now, I will say the other thing about it is when you want to load libraries or packages, I think R is easier for that. I know that for a fact because I've tried to do it in Python and been like, ah. So, you know, to me, getting started, I would probably use R just because the whole environment itself was a little more user friendly, even if the syntax might take you a little longer to catch on to than Python, perhaps. But really, it's an individual thing. I hate to say that, but it's true. Um, so, yeah, some people really do think R is easier to learn. Because even if the syntax is a little, you kind of have to get used to that. the environment itself and kind of like the training wheels, it seems like you can take off a little faster with R. So um, I also think R is, I hate to say this, it's better for like simple visuals for publications. Python can produce great visuals for publications, for sure. They both can. But if you just want something nice, clean, and simple, R is really good for that. But both of them you can customize pretty well, though I think it's easier to customize in R. I mean, I have for publications, I actually have a specific script that I often will pretty much always use and it's already ready to go that I've developed over the years. And you could do that in either too, but I think just a nice visual, clean style. So yeah. Okay. Is R better at data visualization than Python? I don't know if I would say better. I think it's more, I'm going to be honest with you. I think it's more straightforward. Let me also just say though, you have more like visual packages in R than you do in Python. So, yeah. Okay. Let's see. Yeah, anything related to medicine R, technology, computers, Python. I think that's a great, yeah. So if you're like, yeah, tech, comp sci, yeah, definitely probably want to go with Python. If you're more bio, yeah, medicine, health, um, ag, any of that, I would probably go with R. But again, you can kind of ask around. Econ. Sorry, I wasn't trying to leave you out, econ. Um, Man, you know, it depends. I probably are, but if you want to learn Python, go off. But I would say R. And let me just also tell you, I'm an R person, and I know Python from some work with it. And this is coming from someone who's a biologist, right? If you talk to Dr. Fowler, she's a pure data scientist, right? So she's going to have more insight into that. Like, okay, like she probably uses, I know she uses Python a lot more. So, yeah. Cybersecurity, probably want to use Python. Yeah. Cool, cool, cool. What about energy and earth events? Oh, that's in the repository. We're going to talk about that. Don't you worry. Um, but I would say either. That's the thing. Like for me, it's not so much about the data set you're doing at ASRI. It's about where do you want to go, right? Because you're learning this language to take you, you're just to where you want to go. You're just using these data sets to kind of get you riding the bicycle. Okay. I'm gonna let y'all do the research on that. Like if you're asking like, you know, if I wanted to do this, what would I do? Right. I mean, like which package? Oh, yep. Okay. Data science, definitely Python. Awesome. So, all right. So let's see. I'm gonna make sure I've covered everything I want to real quick.
And you can keep moving forward. I will keep trying to field the
Okay.
questions in chat. If I see one I don't know, I will
Yeah.
let you.
Cool. Yes, that's cool. Yeah. I'll let y'all handle them because some of y'all are answering wonderful, beautifully. So I know many of you are graduate students, so you know a lot about this. You can help others as well who might be new. So oh, okay. Oh, I'm trying to go to the next slide. There we go. So here's some guiding questions as you're deciding here real quick. So do you have any experience with programming? So some do find R easier. Some people find the syntax specifically of Python easier, but like in terms of just getting started, if you're a baby, unless you're a comp sci person or you're going to do like, tech, big data, um, R is good. Okay. So, oh, here, let me move this real quick, y'all. I've got something. There we go. So for ASRI, we will be using web-based Google Colab for Python beginners. And that's pretty easy to learn. It's true. But it won't be appropriate for like large projects because you basically can't save stuff very well in there. I don't think you can at all. So you have to like re-upload what you need, right? Every time, which is not the case in R, which I love. Okay, oh, all right. Do you think you'll use programming concepts in the future? So if you plan to program a lot, right? Python. Cool. So you can kind of be thinking about these as you're trying to determine how do you plan to apply programming skills. All right. If you're going to be creating figures for publications, if you're going to be focusing on statistical computing and data analysis, modeling, right? You can do machine learning in R. R is R works for that. R is commonly used in life sciences. I mentioned before, for the figures. I already mentioned that. So yeah. So you kind of just have to think about what track you're on and And that can kind of guide which language you want to use. Okay. Now, you're not locked into a language forever if you learn it, right? Let's say you're an ASRI and you learn R, and then you are taking a class and they're making you learn Python. I think that's awesome because then you'll be bilingual, right? And the more languages you know, the better. Excuse me, I'm get a cough. Okay. So I also just want to show you some links for R and Python, which I think are really useful, that the ASRI organizers have put together for you. Oh, also though, really fast. Now I don't have Python open. I just happen to have RStudio open. I'm just gonna show you. No, I don't have Python open though. Sorry, guys. Um, but like I'm going to walk you, for those of you who do the R sessions, I'm going to walk you through what every single piece of this means, like as if you were 5 years old. So just know that. But also the Python sessions, they're also going to really, we're going to hold your hand because we don't expect you to look at things. Hey, I still have homework from one of my students from, anyway, that's still loaded from earlier this semester. Sometimes stuff just pops up. If you use R, you might notice like, oh, how did this just popped up again? That does happen. It's not a problem. Okay. So I'm gonna show you these links. Um, and where are they? You guys are so patient. Thank you. All right. Um, I'm trying to find the links. Oh, here it is. Let me pull them up over here. R versus Python. Here we go. And I mean, it's R or Python, I guess. Okay. That's the schedule. Sorry, y'all. Let me try this one more time. Ah, here we go. Okay. So look at these resources I put together for you. Yeah, so for this is for R, there's a Python part, don't worry. So, let me just say this. If you're an R person, and I know they've given you these instructions, excuse me, you must download R from the CRAN. It doesn't matter from where, because they're all different, it has all these different cities. It doesn't matter, but you have to do R before you do RStudio, please, because if you don't, weird stuff happens. I won't get into it, but just know. Okay, R Cloud is awesome. They didn't have that when I was starting out, and that would have saved me some tears back in the day. All right, useful.
May I
Go
interrupt just briefly?
please.
This Google Doc that Dr. Dodd is showing, I'm putting it in the student binder. So you can get it from the student binder, which you know is in key links. Thank you.
Yay! Awesome sauce. Thank you, Dr. Holden. Yeah, so like, oh man, look at all this. So, I'm not going to go really far into these. These are for you to explore. So this is not like we're doing a lesson on these today. That's not what's happening. But Shiny this is really useful for data science and for Python. Actually, Python or R, or GUIs. We call a graphic user interface a GUI. So anyway, I love Shiny. Because you can, yeah, it takes you through. She's trying to get me to do cookies. All right, with apps. Oh, that's another thing. Let me just say, if you're like writing apps and stuff, right? That's a Python thing, right? Python's more general. Okay. Um, so, oh yes, these are such good links, y'all. Oh no, wait a minute. I saw this. I thought this worked for me earlier. Did I lose it? No, okay. I'm gonna have to figure that one out. Sorry, y'all. I guess I was looking at it last night, but it worked, I thought. Okay, I will figure that out. Because there's an intro to statistical learning in our textbook and it's available online. So I mean, I've used it. I have a link, so if I have to, I'll replace that link. So this is something you can look through and learn with. Now, Tidyverse is used, well, visualization, other packages as well. You can go explore Tidyverse. I use Tidyverse extensively. It's a package in R. But another cool thing is, yeah, R for data science. This is a book that well, I have, I have perused. I have actually not gone all the way through it because I've used it for the specific things I needed and I would look through there. So you can read it online. You can buy the book. I actually, I did it online. So, and then this is cool because the R graph gallery, um, so it's just showing you different charts that you can make, right, with R programming languages.
I found
Different
one,
pot.
Dr. Dodd. Do you want to can I share my screen and you can tell me if it's the right one? I'll put it in.
Oh, sweet. Cool.
And if it's not
Let
the
me
right one,
stop share.
tell me.
Yep. Charter statistics with R. Yes.
Okay, I'll add that one, you guys, so it'll work.
Cool. Awesome. Thank you. All right. And that stuff happens, you know. Okay. Cheat sheets. So again, R has different data visualization packages. So ggplot2 is usually it's like the most used one, I think. It's the one I've used forever. That's the one I will teach you in R to use. So there's some cheat sheets. Love that. So that's the R kind of, you can explore those resources and play around. Honestly, these are great links and these are great jumping off points. When I was first starting out, I'm gonna be honest with you, I would Google like how do I find a book about, doing this in R, or like how do I find a book about like show me a book about machine learning that I could purchase or to check out, in R, right? So resources abound, and most of them, and pretty much, I mean, unless you want to buy a book, they're free. Or you can check them out from the library. Support your public libraries, folks. So yeah, and they can do interlibrary loans. So Python, oh, man, I will say, Python and R have they have, different looks. I love R, and you can customize R, but like I always thought Python looks so sexy and sleek to me. I don't know why. But you've got beginner's guide. Like I love the Python website is really beautiful because they go through like facts. So you can check this out, right? So I'm just showing you this stuff so you can you have a jumping off point for your own kind of research to figure out. You may already know, like, okay, well, I'm a bio person, or oh, I'm a physics person, I'm gonna do R. Oh, I'm gonna do Python because I want to do data science, or you know, comp sci. Okay. Scikit. This is for machine learning. There it is. So this is really useful as well because it's showing you clustering. So these are some of these are different machine learning techniques, and like kind of a jumping off point, because clustering is an umbrella term, right? With k-means, k-means. Let's see, k-means and k-nearest neighbor would be on here too. You can't see k-nearest neighbor on there. And then hierarchical clustering, random forest models, because that's a form of regression. So this is really nice. If you are getting into machine learning, you can kind of come in here and play around. I think that's a good one. Oh, Seaborn. So, okay, in Python, Seaborn is kind of like the main chart maker basically. Okay. So you can see here examples and follow those, right? And you can see the code that went into it, which is nice. So, but yeah, if you're an R version or Python person, there are a lot of similarities, honestly. I mean, I could look at this and figure it out. And I would call myself still a beginner in Python, even though I'm pretty advanced in R. Okay. And then cheat sheets, getting started with Python.
There's a question about Power BI and plotting being
Mm.
used. Are they? I guess my answer to that, you guys, is you can use anything you want. In
Yeah.
the end, I mean, that's the bottom line. If you know how to do that, for sure.
I'm trying to see. Yeah. Let's see.
That's the only real question. Everything else we've been able to pretty much answer.
Yeah.
There was a question about packages. I said the group of code that perform a specific task. Hopefully
That's right. And here's the deal, guys. If I say something today, like this is just an overview, I just want you to know, like, I do not want this to overwhelm you, because like this is just to give you choices. Right now, there are no wrong answers and you cannot mess up. There's no way. So like, to me, you have a beautiful, like, this is a fun experience that you're getting to explore. You will not take a wrong if you start learning Python, you're like, oh, I really should have learned R. Well, now you know some Python, right? And you could still learn R. Like, you're all very young. Nobody here is dead yet, so you have time, right? So I did also want to mention, somebody asked, I downloaded RStudio before the program. I'm gonna be honest with you, I think you should uninstall RStudio and then download R. Here's the deal, real quick. R is the actual statistical computing software. RStudio is like a user-friendly environment that runs R. So R is the base. It's like the little oh, it's like the little battery that's running our studio. So you need a battery for our studio to work. They're not, it's not that. So the difference is just our studio runs R in a user-friendly way. It's kind of like R is the guy behind the curtain and our studio is the Wizard of Oz, like the guy, the big head, I guess, if you've watched the Wizard of Oz. I think Python is the boss of all languages. Hey man, go off. Yeah, I like Python. Fine. Okay, yeah. So and we're going to get into actually looking at some data sets here in just a minute too. So to help you come up with questions. So, but I'm just kind of, yeah, showing you some of this stuff. Data Camp is good for everything, I'll be honest with you. I love Data Camp for everything, actually. And it has it has grown in the last years. They have so many cheat sheets in it. Like this kind of stuff did not exist when I was starting out. I also want to show you something else. Do you know about Stack Overflow? You love it. You can ask, actually, hold on. How to do a, nope, how to do a t-test in R, what? R's, Stack Overflow. Haha. So that's the thing. This is the community that helped teach me how to use R. Stack Overflow is great for questions because here's why. It has humans who have gone through and said, oh no, this is your problem, and here's how you fix it, and oftentimes with an explanation. I strongly advise, and I don't know if, Dr. Feller can also tell us how she feels about this. With the advent of large language models, people, they can put code into it and it can spit it out and it can troubleshoot code fairly well. But I really caution people, do not, if you can help it, I mean, just don't. When you're first starting out, do not use AI. Now, if you're like really need, like, I can't imagine somebody is a beginner right now, at least, like really needing it, like for debugging something big, just because you have to struggle to learn it. And if I feel like if you don't really, you have to go through the steps. And I'm not trying to make it harder on you. Like, if you're like, oh, I just want to know how to do a t-test. Why can't I just ask, a large language model how to do a t-test? Well, one, I will tell you, because I've done it because I've just been I've played with it before to see. And sometimes it gives you stuff that is not right. And I promise that's true. Like it will give you stuff that doesn't even run. Sometimes it does give you stuff that runs and sometimes it doesn't. So, and maybe you have, used it before and it's given you stuff that runs, but it will not always give you correct code, or it will give you a weird way to do stuff that you really shouldn't. You should learn how to do it another way because it's easier, or, you have to actually learn the language before you can use it, right? You don't want to take a shortcut. So I'm just telling you that because Stack Overflow for me is kind of like, if you need to ask a question and figure out how to do something, Stack Overflow is to me best, right? There are other online communities as well that do that. So, oh, I didn't mean to do that. There are other online communities that can do that. But Stack Overflow is kind of like the old school kind of thing. Okay, so with that being said, I showed you that stuff. So now what we're gonna do first, I'm just like hammering through here, right? So are there any big pressing questions about this before we start looking at some data sets in the repository?
We are all good to go.
Okay. And guys, I hope if you think, I don't want to go too fast, but number one, you are welcome to go back and watch this video. It is not gone forever. I get excited, and I mean, one of my biostat students is actually here, and she knows. Like, I get so excited sometimes I just like go off a million miles an hour. But you can always go back to the video, and we're just gonna kind of walk through the process right now. Cool. All right. So, alrighty. So, so today what we're gonna do? Yeah, just throw it out there. You got a hand up?
Yes, good morning. I just want to ask, how does Jupyter in Python, is it the one we'll be using, Jupyter Notebook, or we're using another one? Jupyter Notebook for Python.
Oh, Jupyter Notebook. Yeah. Yeah.
Yeah.
So I think you'll do Google Colab in a Jupyter Notebook. Yeah. Yes.
S-
That's a good
So,
question. I should have
is
mentioned that.
that, yeah, is that okay? So that
Yeah.
we'll be using that as well. Okay.
Yes. Yeah. Thank you. Yeah. Because when you're working in Google Colab, you're usually in a Jupyter Notebook. Yeah. So yes. Thank you. I should have mentioned that. All right. That's awesome. Okay. You guys want to look at some data and see how I wrestle with the data? You want to see how? Yeah. Yeah. Cool. Okay. There's one yes. We got one yes. So we're doing it. Okay. Okay. Well, I do want to ask one more question. How many of you have opened the data set you think you're going to use and you're like, oh gosh, oh no, oh, I am nauseated. Help. I don't know what to do. Yeah. I freaked me out. I went to sleep. Yep. That's the best thing to do when you're freaked out. Man, just go to sleep. All right. So many tables. All right. Yes. See, I love doing this stuff because here's the deal. I want to let y'all in on a secret. And it's this. Data analysis, statistics is actually, after a while, now it could be hard for a while, but like it's kind of like having a superpower. 'Cause some folks, like once you get it, once it clicks, you can do so much stuff, and it's kind of just like you're solving puzzles all the time. If you like puzzles, and I don't necessarily mean like you know the puzzles you do on a table, I guess, but like Sudoku or anything like that, then it's a nice mental exercise, and also it will keep you happy and healthy because you're always learning when you look at new data. Okay, enough talking. Well, enough talking about that. I'm going to pull up. So what we're going to do is I have randomly chosen data sets in each of the folders of the repository, literally at random. And I've come through, I didn't come through them very hard because I want you to literally see when I open a data set how I do this. Now, let's quickly just touch on a couple of things. First, to me, like when it comes to science, right? You're doing it in one of three ways. Well, and this is like very broad. So just walk with me here. You are either this is not what you're doing at ASRI. You might be the kind of person, you come up with a question, right? You use the scientific method, how you learned it as a child, right? So like you come up with a question, right? You design an experiment, you collect the data, you analyze the data, right? That's what I usually do. That's what a lot of us usually do. If you're a data scientist, you might be collecting the data from repositories and data sets and collating them, right? To answer a question. But at ASRI, we're kind of teaching you this in a backwards way, which is not bad. It's, I think, fun because it's kind of mental. Your brain is growing. So you are getting a data set and then told, figure out a question, which I think is super fun. So that's what we're going to practice doing on 4 different data sets, maybe 5. And then the other way you could do it is if you learn statistics well, people actually will come to you. I've done this if I've been hired as a statistician by a handful of folks, like, people will have you freelance or, um, I've had folks like in the education sector, several actually. One person did higher ed for her PhD, and they were allowed to hire a statistician to do their statistics. And they come to you and they go, here is data, and here is the question. Will you just analyze it? Which to me is the easiest kind because I didn't have to come up with a question. I didn't have to come up with the data. I didn't have to design the experiment. I just have to know which test to apply, which you're going to learn next week. So don't worry. So those are my favorite because it's like just snacks, just candy. Okay. So let's look at data. All right. I want to share with you. You know what? Yeah. Here's what we're going to do. I've got the data sets like queued up, the CSVs. So when you go to the repository, you know what? Let's just walk all the way through it. I apologize if some of you are like, no, get to it. But I want to see everything. So this is my computer. Yes. So here's the repository, right? Bless it. Yes. Oh, this is the overview. Excuse me. Okay, it's in there. There it is. This is population. So it's here. Here it is. So here are your various folders. Okay. In agriculture and food security, I just went through here and I was like, oh no. And I just went, oh, farm income data. So y'all, I'm sorry if this is not your data set, but that's not what it's about today, just so you know. So, because I know some folks will be like, no, do aquaculture. That's what I chose, help. It's actually not about that. It's going to be about the process. So if you take notes or you rewatch the video on the process, you can apply it to your data set and you will be so golden, okay? So awesome. I have the question in my head. I just didn't have it in me to open the humongous data sets. That's fine. Yes. Yeah, the question is the hardest part, which is why I'm gonna help you. Because it's tough. We have lots of practice. You know, if you're pretty new to this, I always tell my students, they're like, how do you know all this? I'm like, I've been doing it for like 20 years, y'all. Like, you can do it too. All right, so I pulled up the farm income data. Now, here's the deal. All right. Okay. Ooh, fun. So I'm gonna ask a silly question and I'm gonna pull the chat. So
By the way, if you have a yes or no, we have a really cool way of doing it. You just ask if it's a yes, use a check mark. If it's a no, do an X and it'll count for you. So you don't have to
okay.
go scrolling through it. So if it's a yes or no, that's
Okay, that's not a yes or no though, but okay. Well, so I want to ask, when you open a data set for the first time, what do you do? What is the first thing
so that's a
you
chat question. Yeah,
That
she's
is
right.
definitely a check question. But yeah. I look at the names like, okay, there we go. I mean, the first one. The first one. Oh, yeah. Okay. Staring at her computer. Okay. This is hilarious that y'all immediately like, yes. Okay. Some of you are getting ahead of yourselves, but that's good. That's fine. So I always ask this in my biostats class, what do you do? You know, and a couple of students will get it, but some of them will be like, I don't know. Yeah, you just look at it. You literally just look at it. And I know that's so simple, but people will open a data set, right? And go, oh gosh, and like close it, you know, like they just seen a snake or something. And yeah, you just look at it and, you know, you won't fear something you understand, right? So, yeah, all right, awesome. So I'm going to show you how I do it. You can do it however you want. And how you come up with a question for it, right? Because now the disconnect is, right? Yeah, you get exhausted reading the data. I get it. So I'm going to kind of show you how I go through stuff. And then like, okay, I have these data. Oh, so much. How do I come up with a question? Like there's so much, right? Okay. I love new data sets because it forces me into like beginner's mind. I don't know if you've ever heard of beginner's mind. It's a thing in Buddhism, like where it's a thing really just behavior. But it's where you you are a beginner again, right? And you're learning. We are always learning, no matter how far we are in our careers or how much we've been to school or anything like that. So when you stop learning, you're done. All right, so let's look at this data set. I don't even know what everything in here is, and I'm not scared. Okay, so now you will want to know eventually what everything is, right? But this is y'all. You're seeing me see this for the like second time. I mean, I kind of just went, oh yeah, farms. Okay, so we're gonna go through here. So all right, I see I have years. Now again, I'm gonna show you my process. So I'm looking. Okay, I don't, you can go ahead and look at all the columns if you want, or if there's row data, you could do that. But I immediately start like dividing the data into, is this junk? Like, I don't know, some of this like publication date. If your publication date, if that doesn't matter to you, and in fact you can like go down, right? Publication date, oh, they're all the same. I would probably get rid of that, right? Like it's all the same. It's just telling you some information about where the data came from. So I have a junk. That's my, when I'm decluttering the data and cleaning it up later, I know I will take out that. So I go column by column, but I think about, is this junk? Is this a potential category? Or is this a number, like some sort of continuous numerical measurement? Okay. So if you it's almost like when you go through a data set, I don't know if any of you have ever decluttered a house. You're just, or like if you've organized something, you're just organizing the data in your mind. And for me, now you can choose your own. You can, but I always do, is it a category or potential category? Is it a numerical continuous variable, like a number of some sort, right? That I might use as a potential variable. It could be independent or dependent. We're not there yet. Don't worry. We're just dividing things. Or is it junk? Yes. Yeah. Exactly, Derek. Yeah, man. Exactly. Perfect. Yeah, that's the thing, guys. You don't want stuff in your data set that's just you don't need per se. Now, I would, if there are other variables that you might use, sure. If you are an absolute beginner, honestly, I would get rid of every variable you're not using. Honestly, because it makes things easier for you. So that's how you clean data. Yeah, clean data like Derek. Yeah, that's awesome. Okay, so let's go through this, right? Year. All right. Also, I always scroll down a little bit because, like, what if it was all 2025 data? That's not, right? It's good to know, but it might not be a variable for me. Oh, dip. Oh, look. Oh, whoa. Oh, okay. It's before most of us were born. Okay, that's cool. We love that. So we go back. This goes back to, oh my gosh. Neat. Lots of years. Okay, so here's, again, we're going to walk through this, right? So, yeah, we know we have lots of years. Now, here's where in my brain, I go, you're literally watching me do this in real time. So, in my brain, I go, all right, I got some years. Years can be a category. I could compare something across years, right? In fact, I would even I have a board behind me. You don't need to see what I'm writing, but like, I would have a notebook or something. I'd be like, all right, years. You could also, in the data set, like this could be a category, or you can use years as a continuous variable, right? If you're like looking at a time series, right? Which is just across different years. Not as a category, and I'll explain more of that later, don't worry. But year could be either. Because you might look at like, just trying, if there's a relationship between, the passage of time and some other variable. That's one way you would use that potentially. I often use years as a category, but okay. So we have a potential variable. You could even like mark it. You could color code these, right? You could be like, oh, this could be, continuous or categorical. So I'm going to call that yellow. I don't know. States. Okay. Again, we're doing the whole process. Oh, okay. So I've got different states. Okay. Got that. Now, this state will always be a category, right? Now, this says US. I guess this is for the whole US. I say, I guess, because when you first open a data set, you might be like, I don't know what that means, or I don't know what I'm supposed to infer from this. Usually there's some sort of, not always, but there's often some sort of dictionary or something either on the website. I know that there are links, right, where there's a document for that particular folder in the repository, and it talks a little bit about each data set briefly, right? Some of them have those dictionaries, some of them do not. I'm going to show you one that has a dictionary too, but some of them don't, and in that case, don't sweat it. Like, don't be like, oh no, this means, just be like, okay, I guess I'm not going to analyze that. Now, you don't want to do that on every variable, right? Excuse me. But this is choose your own adventure. So, you don't have to be like, I don't know what that means. Everything is wrong, right? So, okay, I'm inferring here though. I would go back and do my due diligence, but we're just starting out. This is state, right? This probably means the whole US, right? Now, again, go check that. You don't tell me if I'm wrong too. And then, we start getting into states down there, right? That's always going to be a category. Now, again, you don't have to color code stuff. I actually don't, but I'm telling you, if you're starting out and this helps, okay, that's a potential category. Great. I have no idea what this means. I'm sure it means something, and I'm going to go back and do my due diligence to figure out what it is, because there are differences here. If somebody knows, or you want to tell me what it means. All right, cool. Then yeah. So this, I don't know what that means. It doesn't look interesting to me. I myself would put this in the junk pile, but maybe it's something, but you still should do your due diligence before you throw it in the junk pile. Like, okay, I'm going to try to figure out what this means. Maybe it's in a data dictionary. If it's not, don't sweat it. That's okay. People put weird codes in there sometimes for other, like, whatever agency was using it, or compiling the data. You know, it could just be something, it doesn't matter for you. So don't worry about that. Okay. Now, ooh, this looks fun. Variable description total. So I assume, where do we locate this data? These data are all in the, this is all in the repository, but if you're talking about like the, you know, if it has a dictionary, it would be actually in that, it would be in that folder. Are you deleting them or just hiding? Actually, right now, I'm not doing nothing because so that's a great question. I'm glad you asked that. Like, are you deleting or are you hiding? So when I first go through it, I don't touch anything, right? I'm just like, okay, what do I got, right? And then I'll go back and go, okay, this is my junk pile for me, at least, right? And you get to choose. I mean, I am, I'm a purger. This is true in all areas of my life and a minimalist. So if it's something I'm not using and I'm not going to use again, I'm going to delete it. But you do not have to do that. You might want to hide it. I have gotten myself in trouble before. Well, not in trouble. I've deleted like a column from a data set and then been like, oh, I got to go re-download it. I want that now. So hiding is probably the best bet. um, I'm a deleter, but just, yeah, only in your own copy. She is absolutely right. That's the thing. Cause like I said, I haven't got myself in trouble. You never delete like something you can't get again though. Don't ever delete anything you can't go back and get again. Why a state a category? Do they all have the same values? Yeah. So here's the deal. As we go down, right? Look, watch me now. Right? Oh, dip. See, so there's Vermont, Georgia. So it just says US there, right? And this is why it's really important to scroll down, right? Because if you just and look at the data thoroughly, right? Because if you just, this is also helps you kind of just get a sense for, are there missing values? Because if I just looked at the top, or see, here we are again with US. Okay, right? So, you know, you may want to separate those out. That will be part of your cleaning regimen for your data, but we're not there yet, right? We're just getting to be friendly with the data. We're getting to know each other. We're having tea. Okay. So artificial key, yeah, I would hide that, but I'm not doing anything yet. I just know in my brain, I'm going to hide it someday or delete it. Don't delete it, just hide it. So variable description total. So this is probably the total description of the variables. Like you can just kind of infer that. You may not have inferred that at first, right? It may take you a minute to get it. That's okay. Doesn't mean you're too slow on the uptake at all. Okay. So, okay, that's a description. Now, I will say, you know, as a data person, if you, and we'll talk some of these things like how does this work in R? Will it run slower? We were actually going to talk about all that next week. I hate to say, guys. So we're just walking through the process because we're going to get you a question from all this. We're going to do this with 4 different data sets. And by the end of each one, we are going to have a question. I'm going to give you some example questions. Okay. So here, variable description total, this is pretty cumbersome, right? I just like, this doesn't seem like, I mean, I guess it could be a category, but then I look over here and I go, oh, thank God, those are a lot easier. Like this is just describing, right? Cash receipts, all commodities, all, well, these are encased in that, right? These columns would be easier to work with, but let's look at what we've got, right? Okay, so I see here, these are broilers, barley, and actually it looks like I need to look at them together, right? All broilers. That's a very Arkansas thing because we're a chicken state. All barley. Upland cotton lint. You notice cotton lint is divided, okay? So there's some nesting of some of the variables, and that may not matter for your question. We're just evaluating what's here, okay? We're not even thinking about questions right now. I'm just like, oh, this is like a category, right? Whether it's what kind of commodity it is, basically, right? And I'm going to go down. Oh, see how things have changed. All right. Be sure you scroll down. That is like the number one thing that gets people. They're like, oh, I wanted to ask this question. And then, or they like look at the data set and they see that the column is like, and we'll see this later, like number of deaths from a particular natural disaster, and there were none recorded. Yeah, you need to look at the data. And she's like, you would know there was no data there if you look at it, right? So that's not a good question. There's no data. So, okay, so we've got some different things here. Do not let this overwhelm you. Right now, we're just like, oh, look, categories. Got it. Category. Check that off the list. I'm going on break. Okay, so not really. Okay, so Same here. Okay, miscellaneous. Like this seems to just be modifying this, right? But it doesn't really matter right now. We don't have to really worry because we're just calling it a category. I'm putting it in my category bin. Okay. Again, you don't have to color code this. I usually don't actually. I just remember. But if you're starting out and you're new, this could be useful. Okay. So amount. Oh, this is where stuff gets fun. Whenever I see numbers, I'm like, yay! Because it's a potential response variable. Now, there are certain analyses that don't require a what we call a continuous response, just like a number of some sort. It could be a yes or no. Do not worry about that right now, okay? Because that will come, we'll talk about that next week, potential analyses you could use if you're an intermediate person. If you are first starting out, I really highly suggest that you ask questions where the response variable is a number and not like yes or no. Because then you get into some higher level statistics. So that is my suggestion to you. But here, oh, a number. Okay. So this is a number. I'm going to call, my numbers are going to be, oh no, purple. Yay, this is a continuous variable. It's not a category. I don't know what those numbers mean. What do they mean? Oh, okay, this must be in thousands of dollars, right? And this is farm income data. So that, that aligns with what I would know about this data set, right? Okay, this is telling me what these are. So I don't really need this, but I would leave it here because I would forget. Like what, or when you get to cleaning your data, you can like change your column. But right now, we are just figuring out what categories and numbers we have, right? We're not even worried about questions. We're not cleaning the data. Cool. We're just taking it step by step. Probably junk. Let's check chain type GDP deflator. I don't know what that means, but they're numbers, so I will leave them. They seem to go down. And so I would look in the data dictionary for that. I'm going to leave that for now. It looks like, if I'm looking at it, right? Okay, these are numbers, and sometimes numbers can be used as categories, as in the case of like here. Sometimes people code categories with numbers. You got to be careful of that. But these seem to be continuous in some way. So I'm just gonna code it. It's a number. I don't know. We'll see. Okay, now I know where I have categories versus like a number, right? All right. Now, I'm not going to clean the data yet, right? I'm going to figure out my question. And this is where you do not want to get freaked out because this is where you could freak out, right? You're like, okay, now I have all these things and I got to come up with a question. Okay. Well, here's where the first thing I do when I want to come up with a question is I think about what could be my dependent variable. What was something I think it was really cool somebody measured? This data set is easy because you have, this could be something. I don't know what it is, but I'm just coming up with a question for funsies right now. I would do my due diligence, maybe, and say, okay, so let's say I figured out what chain type GDP deflator meant. I looked at the data, if there is a dictionary. If there's not, honestly, I would just ignore that. Don't sweat that. You're good. But look, where are my numbers? One, there's one. Okay. So that is my dependent variable. I have found it. I have found you, my love. Okay. Yes, excellent. Y'all are doing so, thank you for answering those questions. You guys are doing great. So we have found the dependent variable because it's the number. Now you may have, and I'm going to show you others, data sets that have multiple numbers. You're like, what do I choose? We'll get there. But this data set's actually nice. Thank you, data set, for being easy to start with.
I'll jump in here real quick. So
Yeah.
you can make your project as complicated or as simple as you want. And so I want to make it clear to everybody in here that for the purposes of the ASRI, you could stop at one variable. You could stop at one. Analyze it multiple ways, make multiple graphs, but if you do that, you've accomplished the minimum goal. And then you can do a lot more if you want, but you don't have to. So if somebody comes to me, I've only done one analysis, I'll be like, good to go, next person, I've got to help them. The reason for that is because we want everybody to know how to deal with data sets, how to approach them, how to ask questions, how to test hypotheses, how to do statistical analysis. And there's some students who will be stuck at step 1. And so we've got to help those people. Then we're going to go ahead and answer all those more complex issues, right? And I am not saying you are done if you don't want to be, meaning I'm not the teacher who's going to be like, nobody do more. Do as much analysis as you want with as many data sets as you want in the end. But when you are in a working group, when you are trying to help other people, remember, if other people are doing 17,000 other things and you're just doing one, you are good. This is why ASRI is so successful, because we have such variety of spread, right? We have students who start with just so little and still grow so much because nothing versus analysis, right? And we have students who've coded for years, done statistical analysis, and they want to take this to the 17th layer. Do it. Just remember not to compare yourself against other people. This is not competitive at all. This is collaborative. Our goal is that every student in here gets the stuff done. And if we succeed as a whole, that will be 10,000 times more important to me as each individual little thing that's happening. Frustration is part of it. You must be frustrated. If you're not frustrated, we haven't done our job. So if you're not frustrated, that means you're not pushing yourself far enough. How can you push farther? Dr. Dodd just said, ignore some data sets, ignore some columns, or not. Dr. Fowler yesterday opened a can of worms I never want to open, and that is, if you are at that level, you're a grad student who've been doing this for years, you want to push yourself farther, combine, dare I say, data sets. You can look across data sets. Everyone in here can be challenged, and that's what we want. We just don't want the challenge to be impossible, right? So be careful. When you get so big and so ambitious, you can back off a little bit. What is our minimum? One analysis, one data set, one variable, one graph. Minimum, yes, but sufficient. And for some of us, that's what we can do for right now. It's okay. Dr. Dot, we're going to do a quick little break at 10:30, but we've
Yeah.
got about 13 minutes. You want to approach another data set? We might just do 2. We might not have.
Yeah, I'll do it real quick. I'll just finish this really fast and just say really, really fast, if that's cool. So here's my dependent. Now I go to my categories. You kind of have to here. You cannot do anything really but compare across some categories, right? Whether that's your state or here, right? So then you come up with a question to compare across something. Okay. Now, when it comes to stats, you don't want to have 50 categories. That is at least not starting out. If you're doing comparisons, if you're a beginner. So just know that. So I would say, okay, how does, the income in thousands of dollars of, how does it differ? Because I've got categories, differ by across, say, states or years. Now you may want to collate some of those years, like 2010 to 2020, so you don't have too many categories. But that's how you could do that one. All right, so let's do another one real quick. Yeah, and then we'll take a break. Okay, so let's do, greenhouse gas. No, I want more time with that guy. Let's do, I love this one. This one's a very simple data set. So we're just really, maybe we'll do a little bit of both. We probably have time for both of those. We'll just see. Because I got a really simple one here, which is a pregnancy outcome data set. This one is super simple, and I'm going to share it with you real quick because this is actually really quick. So we can do it in we may even get to another data set in population health. All right. I looked at this. Oh, this is beautiful, right? Because this one is actually really simple. Don't worry. If we have time, I'll show you another kind of more complex data set in population health. Because I downloaded it and was like, oh, that would be fun to show them. I should go with that one. But here, looky here. All right. Oh, I opened it. I'm looking, right? I got different states. Cool. Now I would go further and look further down, but I'm just trying to do this kind of quick. So, okay, I got a category here, potential category, right? Because state. Years it could be a category or a continuous variable depending, right? This tells me the month. that could be cool, I guess. So a month would be a category, right? Now, this is 2018-01. Okay, that's probably January, right? January, February. Oh, okay, I get it. March. Okay, cool. So this is a category, right? Category. This could be both. Pregnancy outcome, whether it is a live birth or a miscarriage, stillbirth or termination. Okay, so pregnancy outcome, this would obviously be a category, right? Whether it's live births, whether it's miscarriages or stillbirths. All right. So this would be a category. Service count. This is obviously, these are numbers. I don't know yet. Like, okay, service count. So this would be, think about this. So first of all, let's just recognize it's a number, right? Oh, sweet, sweet numeric data. Yay. So what is it? Let's see. 2,752. This is likely, or you go back, right? Live births. And again, like I've been doing this a really long time. So I can like, my brain goes, okay, yes, that's what this is. You might be like, what is that? And have to sit here and look at it for a minute. And that's okay. That's really normal, guys. I used to, and even now, sometimes with data sets, I'm like, what is this? And have to sit there for a minute. So don't worry. So like this is 2,700 some odd live births in August in 2018 in Alabama. This is a really easy data set, I would say, in terms of just like straightforwardness. So let's keep going. Rate per 10,000 beneficiaries. So this is the rate of live births per 1,000 beneficiaries. And you'd have to probably do your due diligence and figure out what that means. For live, yeah, that's the rate of live births in August 2018 in Alabama. Okay, so we have divided the data. We know we got some numbers, we got some categories. So now we've got to come up with a question, right? Okay, you can kind of, in your head, come up with a potential question. But, my numeric data, somebody asked, they're like, okay, so is the dependent variable always numeric? Let me just say, and I don't know if I'm going to get murdered for this, but dependent variables, in my experience, having done analysis for years and years, like it's usually numeric, but not always. When you first start out, though, I suggest you stick to a numeric dependent variable. Now, as you advance statistics, you will get like binary operators, yes or no. Do they have diabetes or not, right? And you could use something like a logistic regression. Don't worry if you don't know what that is, to analyze
And I want to jump in and say, independent variables can also be numbers. Like, don't get,
We're getting to that, yeah. Yeah,
I did an explainer on that. Just focus on what depends on what, right?
yes.
If something is dependent on something else, it's a dependent variable.
Right.
Okay. So that's the better way to think about it in general, because that way you don't have to be worried about whether it's a number or not a number and what kind
Exactly. Well, and here's the thing too. You're absolutely right. Right now, I've been showing you like here's a category, and I could compare across categories. But when you have multiple numeric variables, right? Let's say I have, and we'll look at more data sets after the break. But let's say I have CO2, right? Emissions, and then I have year. I could do an analysis where I'm not comparing them across years. I want to see if there've been an increase or a decrease, right? If there's a relationship over time, or maybe I want to see if there's any relationship between CO2 emissions and methane emissions, right? Those are two numeric variables. So your dependent variable will be numeric, yes, in those instances. Your independent variable, you really just have to think, and this is what will kind of be a segue into your statistics. Is my independent variable a category or a number? Because that is telling you, am I looking for a difference with categories? And we'll get into that when we talk about stats on Monday. Or am I looking at if there's a relationship or an association between two numeric variables? So your dependent may be numeric, but your independent, she's right, may be a category or a number, a continuous variable. So yeah, we had a great question in the, or not question, we had a great, well, it was a research question in the chat. Like, so the question could be, and it was good. Oh, did I open? Sorry, I'm impatient with my computer. Could a question be like, which states have the highest rates of live birth during the winter? Absolutely. That is a great question. You'd do some averaging out of that, right? You'd clean the data. But that question perfectly fits this data set. Excellent. Yeah, you do frequency table. Oh, that's good. See, you already know. Yeah. Excellent. And that will be done using R and Python. Yes. Cool. Exactly. The nature of your dependent and independent variable tells you what statistics you'll use. And that's actually what we're going to go over on Monday for sure. Right now, we're just coming up with questions, right? Okay, so that is, we've done 2 data sets. And I think I'm not going to go over, don't worry. We're going to get that break. But really, really fast, I want to show you a scarier data set. You want to see a scarier one real fast for in public health, and then I'll just be like, show you how that one can be just as easy as this one that we just did. Okay, so really, really fast. Don't worry, we're going on break. But I want to show you because I'm so excited. Because now that you've seen those, hopefully big scary data sets are not as scary. All right, so here we are. All right. So check it. This is chronic disease indicators. And this is scary. Right? Okay. Even I think that, I mean, you can think a data set's scary, but you can always break it down. Because you see there's all this noise over here. Oh, it's not too bad. But you see like there's a lot of stuff missing. Oh, I'm scared, right? Just take it piece by piece, right? So year start, year end, we got different years. Some of them are like ranges, some of them are not. You need to bear that in mind, right? Again, I'm going to do this one really quick. But location, right? These are categories. Data source. We might use that. We might not. Since there's some differences and might look at different data sources, maybe I'd keep that as a category, potential category. And here's the deal. Like I said, you don't need to focus on categories. It's just that there were a lot of categories here. I might want to do something like, like I said, a relationship between 2 variables. There doesn't seem to be any in this data set. It depends on the data set, okay? So I've got a lot of categories here, like the topic, health status, cancer, diabetes. Okay, that's definitely, here's a category. Question, recent activity limitation. Okay, so this is kind of giving me insight into this, which is my number. There's my numeric variable. And this seems to be, this is low versus high confidence limit. This seems to be the only dependent variable, not dependent, excuse me, the only numeric variable really in this data set. And that's okay. Some of them only have one, some of them have multiple. So the question you ask will really also depend on the data you're looking at. This is also why you can kind of check around. If you want to practice a particular analysis, then yeah. Oh, also, like, we talked about questions, but you also want to come up with a hypothesis, right? That will require, you want to also have a rationale with your hypotheses. You probably want to do a little background research. You do, just to come up with some sort of rationale as to why you think something happens. So like, if you want to compare live births, number of live births in winter months across certain regions, let's say, you would want to hypothesize like what you think might happen, right? So like, which states do you think will have the most live births in the winter months? And you might do some research to give you a rationale so that you could explain why you think that would be the case. Now, sometimes I'll tell you, like, for example, and I'm not going to get too much into statistics today. That's Monday. We're just kind of coming up with questions right now, and then we can get into stats next week. So here, we're about to do break, but like, look, y'all, numbers, right? And you're like, I don't know what these numbers are. Well, apparently this was the question. Invasive cancer. So you see there's a lot of big differences in what these are, right? So I might need to like organize the different questions, even code it, but this is some kind of category, what kind of question they asked, because these numbers are all telling you different things. So this is somewhat of a complex data set because you're like, okay, like all these numbers mean different things, right? So you probably want to organize them by that. And then hone in, like, what do I want to look at? Do I want to look at the incidence of invasive cancer in all sites versus, in a particular state or across states? It doesn't matter. You could just say, I want to look at, invasive cancer incidence across all states. Maybe you would average them, right? And prostate cancer, or prostate versus breast cancer mortality, that kind of stuff, right? And you've also got things over here like if there's further stratification, but don't let that scare you, because sometimes you don't care if somebody's, it depends on your question. You may not care if somebody is from a different state. You just care if they had, if it was cervical cancer mortality and you're averaging across states. So you just want to compare. It depends on what you want to compare, right? If you're doing a comparison, you could also do relationships, though this data set does not lend itself well to that. So yes, you're going to start preparing questions based on this. So then we would come up with like a hypothesis, right? So if I'm looking at like breast cancer mortality across states and across years, right? And if I just want to compare breast cancer mortality and prostate cancer mortality, yeah, right? Then I would come up with, which one is perhaps having which one has a higher mortality rate, right? And you can go to the literature and see like which tends to have a higher mortality rate, and you could come up with a hypothesis, and why, like treatment options and things like that, right? Okay, yes. So let's take a break because we've done 2 data sets, and then when we come back, I'll just do 2 data sets real quick, and then we'll do this whole like, break out and talk
Yeah,
to each
you
other.
guys do it. Yeah, you guys do it.
Yeah, you guys do it.
You have to understand this is examples, and there's lots of good questions in chat that I've been fielding, but basically all you've got to do is pay attention, try and understand what Dr. Dodd is talking about. If you have a question, ask, and then open your data set. When you come back from break, open your data set because we're going to start working through your data sets. You're going to be doing this. You're going to be putting this. I'm going to ask. So if you haven't done this yet, I'm going to ask for that slide. Remember, you were supposed to either make a Google slide, find a template that you like from Slides Go or from any of the others, Canva. I don't care, but you need to have a slide that you'll share with us by the end of the next session, where you will have written out your name, your topic. This is your data set that you're using, basically what you signed up for, which subset data are you using from that folder, and then your question, your hypothesis, and then you'll have your 3 sources by the end of today. That's in the 3rd session from now. 3rd session of the day. That's what I should say. All right, go to break. I'm going to start a countdown for 10 minutes. We did have a suggestion to have a countdown clock instead of just a simple when to come back. So I'm going to try and do it with a very simple clock. I'm going to start the 10 minutes right now.
So here's the key links. Check it out. And then you go down to student binder right here.
By the way, you guys, if multiple people are sharing, Zoom now lets you do that. At the top of the bar, there will appear multiple tabs for who is sharing. So just click on Dr. Dodd's tab if it didn't open directly, because I was too slow in closing mine. But if you can't see
I'm
who's
share.
sharing, click on her name at the top. It's on mine, it's purple. Or you can reshare. Yeah, start sharing.
I'll reshare real
That'll
fast. And that makes it a little easier for everybody. Yeah, so when I go to the key links, I would bookmark this if you haven't already, honestly.
Yeah.
And then, yeah, student binder. Oh, here we go. Student binder, woo! Aha, repository, there it is, woo! Okay, so this is where the sauce is kept. That was just a joke. I hope I didn't confuse somebody. So here are your different folders, right? So your data set is in one of these, right? So let's say I was going to do greenhouse gas emissions because I know it's in here. Actually, this is one that I know it has a dictionary for sure. So here are the various files, right? And let's say I've looked at this before. Oh, look, greenhouse gas data. There's the data, right? Okay. Here is the dictionary for it. And you kind of have to like look through, right? But just know it's not going to be a CSV file. It's going to be a document of some sort. Now here, every folder has one of these, an info sheet, right? Where it shows you, okay, here are different data sets, right? Sometimes the data dictionary is right here in the folder, right? But not all of them. So like for me, I would, for example, like let's say I want to do energy emissions then for 2016. Let's see, energy emissions. Hey, this data set contains emissions. All values are megawatt. Like this one isn't. Here we go. Now, sometimes I would follow the link just to see. If you do not find a data dictionary, though, do not sweat. I mean, you don't necessarily need one. If it has one, fantastic. But like, here's the data set itself, I assume. So this is where it came from, right? metadata, but like it's it also could help you to read the references. So absolutely follow those links in that sheet, like based on whatever data you're doing, or using, I should say. Right. So where can you find the, oh, okay, cool. Awesome. So that's kind of how you would do that. Let me see. Let's go to their spot. Let's just like, let's run around here. Let's go back to the repository and I'm going to go to Extreme Earth Events. Check it. So notice, okay, I'm going to go to the info sheet here. This is the overall info sheet for this folder, right? This is so nice that y'all made this. They made this for you. So like you get the source link, whatever data set you choose, make sure you read this. This is not the data dictionary that will like tell you what all the variables mean, but this is helpful. I would follow these links because some of the links will have the dictionary with them, but usually if it's going to have one, they have already put it in here. So like here, storm data, bulk, that likely you kind of have to just look. I'm inferring, and I would check this as I open this, that it goes with storm events, right? Whereas I also have, this is probably emergency management data, probably goes with EM.dat full data, right? I'm inferring that. I would open these up and check that, right? I'd be like, okay, oh, this is what everything means. Wow, that's cool, right? But here's the other thing. If I go landslides, fireballs, or meteorites, I don't see a dictionary in here for those. Now, if you look at the info page, you can always say, okay, well, let me just go here and I will see if there's maybe a dictionary on the website, though I'm pretty sure that Dr. Fowler would have put that in the repository though. But like, for example, let's say there actually isn't one for fireballs, landslides, or meteorites. It's not a problem per se, right? Like here, I'm gonna
Always need a dictionary, you guys.
go.
Sometimes you can tell by what things are in there, and sometimes you can't, so that's okay. So
Yes.
if there's a dictionary and you need it, right? Like if you need a dictionary, then look for it. That's great. If it's not available, see if in that data set there's any of the columns that you can understand and ignore the others. I know I say ignore the others. It's okay to do that. It actually is scientifically sound. It's fine. If we find a dictionary, we put it in there. If we can't find one, we don't see it. There's a question chat about tips about formulating your hypothesis. You know, give more examples. So I gave a really bad example. You know, there are exactly 1,255 grains of sand in this pot, although it would be more millions. Like if there's something I can't test, that's a poor hypothesis. They're not really bad hypotheses. Like if you don't support your hypothesis, that's okay. We're happy with you. And at ASRI, that is not our goal to support our hypothesis. I know some scientists do that secretly behind closed doors, but you're not supposed to. It's supposed to be a true, unbiased experiment. What you get is what you get. You can always collect more data if you think you don't have enough statistical power to answer the question. That's okay. That's always okay. So we're going to give you, Dr. Dodd is going to go through another data set and she'll give you specific hypotheses. So listen in for that. I also have a lot of questions about what should be on the slide. I'm preparing that example slide. I will share it with all of you. So just sit tight. And by the time you need to start working on this, we will have it ready for you as a template, okay? All right, go ahead, Dr. Dodd.
Okie dokie. Yeah, so I think we had time to look at a couple more for sure. In fact, and from those two other folders, right? I know we've got about 10 minutes and we'll try to let you kind of work on that. But let me show you. Let's just do that emergency management data. Let's look at that, right? Now that was one that had a dictionary, but again, if you don't have a data dictionary, first of all, I wouldn't sweat it. I wouldn't be like, where is the dictionary? Help me. Oh no. Like if it's not in the folder, man, it probably doesn't exist. And that is totally fine. Is it all right if your hypothesis is, I don't even like to use the word wrong with hypotheses, if I'm honest. They're just not supported, man. Also, I never say prove or I mean, you can say disproven. I don't like to say prove though. But I just, yeah, you gotta be careful with your language there. But yeah, it is totally fine if your hypothesis is not supported. I have rarely had a hypothesis that was just like completely supported by my data, because you get what you get, right? You are just there to tell the story of the data, right? You don't control the data, right? With your hypothesis is not dictating it. Yeah. You're not trying to prove it. Yeah. You're just, and if you find no differences or no relationships, that is also interesting. Oftentimes sometimes that can be more interesting. But anyway, okay, back to data sets, right? So I'm showing you the EM data. We're gonna go to that emergency management data. It is one with a dictionary that I may or may not open up because I think I could probably do this. So the first thing you notice, okay, sorry, is there's some spaces. Oh, I don't like those. So you've got like a lot of missing data. Now, this is actually, I think, a great data set because I've had people come to me for consultations before who are like, yeah, I wanted to know how many, for example, let me just see, how many deaths, actually, let me just remember one. How many deaths from earthquakes in the US over, some time period, right? Across, no, maybe in the world, across countries. Let's just go there. How many deaths from earthquakes in the world across, and compare it by country? Okay, maybe they were doing that, but there were no reported deaths. That has happened because the person didn't really, I mean, I guess they didn't know to look to see if those data are populated in the data set, right? It is an interesting question, but let's just see if we could even do that. We'll get there. Actually, we'll just go ahead and look. Are there deaths? See, you see that there are so many, like there are a lot of deaths reported for some things, but notice there are a lot of missing things. How many things that people are injured? There's a lot of missing data, right? So you got to be careful. You got to be cognizant of that. But if I'm just opening this up, right? Same kind of deal here, real quick. I got no. Okay, that's probably the disaster number. That's my guess. But I would check that with the dictionary, right? That's probably just a code. That's to code whatever that is. So, I mean, honestly, for me, that would probably be junk. Year, and you already know, like year could be a category or a continuous variable if you want to look at a time series, which is just how data, some variable changes or variables change, because you can do multiple over time. I have no idea what this means right now. So I would look at my dictionary. Now, I'm not going to go back and look at back and forth at the dictionary because I want to get through this and then give you time to, run through your stuff. But yeah, in searching for articles, you want to pick ones that actually, all of them, whether they support or refute your hypothesis, actually. Leave nothing out. So I don't know what that means. So I would check the dictionary, right? Glide. I don't know what that means. And it seems pretty empty, but I wouldn't want to go all the way down to C, right? We're doing a little, I've picked up the pace, if you can see now, right? Just because we've done a couple, but don't worry, I'm not going to leave you behind. But most of this so far is like, okay, maybe junk, years, category or continuous. Don't know what sequence or glide means, so I'm going to check those in the data dictionary. But I'm not going to do that while I'm demoing it for you because I'm just trying to get through it, okay? Just so you can kind of see this process. So disaster group. Oh, this could be a cool category, right? Natural disasters, technological disasters, like me when I'm trying to learn new software. No, I'm just kidding. That's terrible. Okay, disaster group. So that's a potential category, right? Okay. But here's the deal. There's quite a bit on here. You don't want to get too bogged down. We're dividing stuff up, right? And then I'm gonna be like, okay, what could I ask about based on, you're gonna hone in on like one or a couple variables. So right now we're just dividing them, right? And then we're going to conquer. How to categorize the data into subcategories. Well, like here's this data set actually does it, right? Like natural disasters, where it's climatological, geophysical, right? So that's another potential category, and that's a subcategory. Okay, so either one of these could be potential, like probably independent variables, right? Now, again, independent variables could also be continuous. We're just categorizing right now, right? We're not getting overwhelmed. The type of disaster. Is it an earthquake? Is it a volcano, right? So lots of categories here, right? That we're seeing. Disaster subtype? Oh, okay. Well, it's in there somewhere. I don't see anything, but I would go all the way through right? And see, okay. And then event name, coal mine, Santa Maria. I'm not sure how useful this would be. I would do my due diligence. I would check with the data dictionary. I'm not sure right now if I were analyzing this data set, I would say this is probably junk because none of this is looking, but I would definitely check the data dictionary first. Okay, country. Country could be interesting. Countries are a category, right? Now, I also want to be clear that sometimes you don't want to have, if you're using categorical data for an independent variable, you don't want to have too many categories. So sometimes you might want to, group things by, say, and you would have to add a category here, right? Say, Asia, maybe continent, right? Hey, wait, there it is. Oh, okay, never mind. Thanks, data set. Always looking out for me. Okay, ISO, this appears to be, right, the signifier of the country. So these are kind of the same thing. I'd probably get rid of that because here it is. Region, oh man, another category. So many categories here, right? And then you've got location. These are so different. Like you could potentially keep this and see if there's anything that comes out as a category, but you probably want to stay broad. Origin, I don't see much on here, but you could go through that and see. Associated disaster, sorry. Drought causes famine. Okay, right? So this is a potential category. So like I'm seeing a lot of categorical data here, right? And I'm kind of going through because, and so I go through each one of these. And if I don't know what something is, I'm not worried about that. Like here's the scale. It doesn't, for me, I'm not interested in necessarily the scale, right, I might care about the magnitude. Maybe if I'm interested in earthquakes, notice most of the numbers in here, which are continuous variables, right? This is numerical. They are mostly like Richter scale earthquake values, right? Magnitude of an earthquake, but there are others as well, such as this might be, is this wind speed or is this, oh, no, let's see. A flood. Really? Square kilometers? Oh, I guess how much it covered. I was like, when I think of a flood, I think of cubic meters. Anyway, oh, there's one. Anyway. Okay, so here is a continuous variable you could look at. Maybe you want to look at earthquake magnitudes, right? Okay, as I'm going along here, got some lat longs. That's just where places are. If you're going to do some sort of geospatial analysis, which I don't recommend unless you want to do, do it if you want to do geospatial analysis, but that can be a little more advanced if you're somebody who's very, well versed with like GIS and stuff like that. Maybe you do something like that, but don't, if you're a beginner, keep it very simple. The thing is, there is elegance and simplicity. And sometimes the simplest questions are sometimes, the most elegant. And like the more you practice this stuff, the better you get at it. All right, we got years. Could be a category, could be a continuous variable, right? So, okay, got a couple of continuous variables so far, telling you exactly when they happen. Okay. Oh, Des. Here's a continuous variable. I didn't mean to sound excited about Des. It's terrible. And you see there's some missing data, but okay. So I have a potential, like I could ask maybe something about how many deaths from a particular disaster, right? Or compare them across disasters or compare them, by region. You see, we already had those categories. I could look at some differences, right? I could also, though, look at maybe years. Have death tolls from certain disasters increased or decreased over the years?
And so that's the question, guys. Did you hear that? That was a question. It was a question mark. Now, a
Yeah.
hypothesis would be there are more blah blah. Or you
Yes.
could say less if you did your research. You did your sort of background research that will teach you in literature searches. You can change your hypothesis before you start analyzing at any point, before you start
Yes.
analyzing.
Right. So like another hypothesis, let's say a question, let's say I'm curious to know if deaths from earthquakes have increased or decreased. This is the question over time. And my hypothesis might be the total number of deaths from earthquakes have decreased over time due to advances in engineering of buildings. That would be a good hypothesis. Every hypothesis, you want to have a prediction, and then if at all possible, a rationale for why you're predicting that. Okay. Now, sometimes sometimes you may not know the system well enough, but there's usually some background research you can do. Also, like notice there's a lot of, like here, I might not want to ask a question about injuries or affected human people or insured damages, because there's not a lot of values there, right? Most of the values here, now it depends on the disaster. Maybe I want to focus on something that I do have damage in thousands of US dollars, right? Maybe and I'll go across here and I'll go, okay, I'm interested in damages. Like, let's just look here. Oh, this was an earthquake. Okay, so I've got some money values for earthquakes, because some of these, right, you're not going to quantify the damage from some of the disasters as you would, like, say, an earthquake. Like, I'm seeing a lot of so this could be a potential variable. You'd have to think about that, because you don't want if these are all earthquakes too, we wouldn't want to do that, right? Because you'd have a lot of missing values. In this data set, it looks like either, DAS, years, those would potentially be good dependent variables to ask a question about, right? And then you have, if you either wanted to do a comparison and compare differences, you've got quite a bit to choose from here, right? So you can kind of hone in on one. If you wanted to look at a relationship, you might even say, okay, is there a relationship between how many people die and the month of the year? Because you have months of the year, right? Like, do more people die of either a particular kind of disaster, perhaps? Is there a relationship between, like, well, that might not work as well. You probably just want to, does it differ? Sorry. See, I'm working through this in my mind in front of you. So, like, yeah, because to me, a month, you could do it like that, like, a relationship. But it would be better to use a month as a category. I think in that instance, so it's not truly a relationship. Is there a difference in the number of deaths from, say, I don't know, tornadoes across months of the year or across seasons? Because you could bin these by season. You could do that. And that gets into kind of creating your own columns, but don't worry about that right now. Right now, we just want questions and hypotheses. So, like, I might say, I predict that there would be more deaths from floods in spring, because that's when most spring flushes fall in certain areas of the world. That would be a potential hypothesis. No, hypothesis is bad. So, we're talking about statistical power. Yeah, y'all, we are going to get into stats next week. It's 11 o'clock, so, we're going to let you,
We're
wait.
gonna do a couple of other things, but if
Yes.
you keep going through,
Okay, one more, right?
if you can do chat
One more.
for just
Oh, yeah.
yeah, you do one more.
Okay.
The 11 o'clock, you guys, is flexible, right? This is us working, and the more examples we have,
Yeah.
the better you're gonna be able to do everything. So I'm perfectly fine with
I
that.
forgot.
I'm
I
gonna
forgot.
working through
Yeah.
chat as well. I have your example slide ready as well, you guys. So that's what we'll do right after Dr. Dodd is done.
Yeah, so really quick, I feel like, now that you've kind of got a little bit of an idea, it's okay if you're like, I'm still not sure. But do it not sure. Just do it. Do it unsure. It's okay. Um, so, like, here, there actually happens to be, I think, a data dictionary for state greenhouse gas data. That's what this is, state GHG. I'm not going to pull it up right now, but I would be looking like, okay, econ sector, what does that actually mean? But I'm looking and I've got ag. I know there's industry on here, right? There's a category. And I'm looking, this is very well organized. These are all obviously categories, right? Fossil fuel combustion, but I would be looking down, fossil fuel combustion, what else is in here, right? Oh, enteric fermentation, right? So, man, there's a lot in here. But yeah, potential category, this is category. And again, I would be going back and forth between my data dictionary to see, okay, like, what everything means. I might even, rename a column so it makes more sense to me. But yeah, so I'm seeing a lot of categories, different potential categories, right? So I just go through this subcategory, like, again, I'm doing this fairly quickly, but you see now that there's not much in this, but I would go all the way down because it may not be something I'm interested in, because there's not much there. Here's state. Oh, right, state. So there's another potential category, right? Okay. And the thing is, you're not always looking for categories. It just so happens these are the first things we're seeing in these data sets, right? And then units of what greenhouse gas. Oh, yeah. So different categories, cool. So this is almost certainly teragrams. And then, but the data dictionary would tell you that. I do greenhouse gas work in streams, or have at least. So this one's CO2, and it goes down, right? The category. This looks to be the same, right? So I might just like choose one, unless, well, let's just see. Because I know that there's probably methane because they're a greenhouse gas. Oh, nitrous. Okay. Then you've also got, yeah, fluorocarbons of various varieties, right? Which are very, very potent greenhouse gases. So you see those. So those are different categories as well. GWP, I'm pretty sure that means global warming potential. And if methane, because CO, yep, that's it. CO2 is one. Again, the data dictionary would tell you this. This is what you'll also find if you like open a data set that's kind of close to your field, you'll probably just be able to infer some of it without looking at the dictionary. But so like the global warming potential of carbon dioxide is set to 1 because we compare them to CO2. Methane is 28 times more potent than CO2. But okay, these are numbers. Actually, this is a great example of where these are numbers, but you could potentially use it as a category. However, that category, if you look, is probably going to be the same as what the greenhouse gas is. Okay, so maybe I don't care as much about that, right? These are how I go through this. Okay, so like, you may not care about the global warming potential because it's basically the same as the greenhouse gas, right? So you could shorten the data set in a way by just being like, okay, I don't want global warming potential because I'm not interested in that. Oh, and here is, so we got to infer this. Here are the numbers. Oh, sorry, I get excited when I see the numbers though. So this is going to be, right, teragrams of carbon dioxide in 1990 in Alaska. And I got it from 1990 to 2022. Oh, yes. So every single one of these, you have a lot of potential here. And you may end up having to retool this data set. Don't worry about that. We just want to come up with a question, right? So I know that the values of numbers I have, which would be potential responses, all these, right? This is amount of greenhouse gas, right? So you have the amount of a greenhouse gas, even by year, though you could do it across years. Basically, you will probably want to ask a question about how an amount of a greenhouse gas, right? In some way. You could even say, okay, so let's come up with a couple. Let's say I'm interested in running a regression for the first time. I want to see. I wanted a simple regression. And if you don't know what that is, that's okay. I would just want to know if there's a relationship. Let's say I want to know if CO2 emissions, right? And again, we're just coming up with a question. We'll worry about how to make the data, get it ready to clean to analyze in this way later. We're just coming up with a question based on what we have, right? So I might say, okay, do CO2 emissions increase with methane emissions? Is there a relationship between the emission of methane and carbon dioxide into the atmosphere? That's a very simple one, right? I say it's simple. This data set, you're going to do a lot of cleaning, but that's okay. We have that. Okay, so then you might say, okay, I predict that carbon dioxide and methane emissions will exhibit a positive relationship. That's the hypothesis because, and you just come up, with it. So because, many of the same processes that emit CO2, or many of the same industries emit CO2, emit methane from some other pathway, some other mechanism. That's just an example. Okay. So there's one example. We can do another one in here. Okay. So let's say, now again, notice my numbers are really all about greenhouse gases, right? So let's say, okay, I don't care about relationships. I want to know if there are differences, because that's really how we bend questions for the most part. So when I say that, I mean like kind of divide questions. So you might say, okay, rather than a relationship, I want to know if there's a difference. I want to know if there is a difference. I'm just looking around in CO2 production between agriculture. Let's just go crazy here. Energy and industry, and I think this is land use, land cover change. I know that's probably like This is land use. This is basically forestry. Oh, land use change. There you go. It was like land use, land cover change. Land use change, and forestry. There you go. So these are different kind of sectors. So do CO2 emissions differ by economic sector, right? Okay, there's a question. So I might say I predict CO2 emissions will be greatest from industry, and you would say why, right? So that's one example there. This is a fun data set, actually. Actually, all these data sets are pretty great. You may also want to ask, like, oh, what's this with animals? I like animals. You might look at the subcategory, like, okay, you might look up what animals produce the most methane. You might want to test that. What animals produce the most methane? Because we know that, some animals are a significant source of greenhouse gases. So you might want to look that up, right? Not look that up, test that. And so you might come up with a hypothesis like I predict, this one's gonna be tough for me. I predict that, yeah, like dairy
Cow.
cattle have the highest greenhouse gas emissions. Right. Sorry, what were you gonna say?
I was literally going to say cow
Cows, yeah.
because I don't know any better.
No, that's what we also you've got like different like crops even. So like you could ask so many questions. And also let me just say, if you're a little more advanced, because I know there are a few of you and not all of you that are a little more advanced, you could say, okay, because some of you, if you don't know what an interaction is, ignore what I'm saying. But if you're more advanced, if you're not a beginner, you could do something like say a multiple regression. Don't worry if you don't know what that is. Or I'm speaking to those who might be like, okay, well, can I do something else? Like I've done all that stuff before. I've done ANOVAs. Help me out. Yeah, maybe you want to know if CO2 differs by economic sector and I don't know, one of these other subcategories, right? So like you can have two independent variables if you know what you're doing. Don't even worry about that if you're new. Come up with a simple question. And we'll get more into that when we talk about statistics, but I just want to say, as Dr. Krakowiak said, you can make this as simple or as difficult as possible, but if you're a beginner, simple, I say simple, you don't have to go too simple, but like you don't want a ton of variables, right? You might want to do iterative multiple analyses. That might be better, right? If you are more intermediate to advanced, you might add in lots of variables. So yeah, so you're doing the alternative hypothesis. That's right. I actually, I almost mentioned the null, and then I was like, I'm not teaching you stats today, so I'm not going to say.
I
Yeah.
hate the null hypothesis, by the way, but there
It's a
are
stats thing.
statisticians who live by it. So
Yeah, it's a
it's
statistic.
it's not experimental scientists lingo. We have experimental hypothesis, and that's what we test. But yes,
Yeah.
we'll talk about it during stats.
Yeah, the null hypothesis is a total statistics thing, for sure. And here, I'll just mention statistical language and like the language of your subdiscipline or your discipline are two different things. I could speak in statistical language and it sounds gross. Like I can say there was no difference between the two groups. That's statistically that makes sense. That's right. But like I'm a biologist, let's say I didn't say what the groups were, right? There was no difference between, I don't know, algal production between, you know, agricultural versus urban rivers. Okay, that is in English, right? That makes sense, right? It's not just the cold statistical results. It's telling you information about the system at hand, right? So that's a quick thing I just wanted to point out. Okay, so we've gone through data sets. Hopefully that was helpful. That has talked for 5 years.
No, that was wonderful because they saw so many different options, right? This is what you're doing right now. This is it. And I'm going to call on you. Once you finish what I'm asking you to do, I want you to do the check mark. And then I'll ask you to share your screen to actually show me that you're done. And that's what's going to get you to lunch. So guess what? This is important. So let's pay attention for a few moments more. I'll show you what I have prepared for you.